Hey, what's going on, guys? WukongJS here. So I keep working on my JavaScript chess engine named Wukong, which is assumed to be running both in browser and in a console mode via Node.js using the UCI protocol intended to be interacting with GUIs like Arena. So in this video, I will demonstrate the UCI implementation and how it works. Basically, the plain strength of WukongJS engine is now, it's kind of absent, I would like to say, yeah, because I didn't really, I just want to make it kind of being capable of making whatever moves, and some very basic, it did implement some very basic stuff like threefold repetitions, like 50 row move repetitions, and actually I've been working on creating, I was working on the code more like than on the plain strength. So I don't know, probably first I will demonstrate what I came up with so far regarding the UCI protocol, and then quickly walk through the implementation, and then we'll probably highlight the further steps to consider and some ideas that I have in my head at the moment. So well, GUI doesn't yet allow us to play, because again, like, the plain strength is very poor, and for those who doesn't understand like the steps within the chess engine development progress, I just don't really get those guys being disappointed by poor plain strength. So it's not a demonstration of a chess engine. it is, but it's not. It's a demonstration of like implementation of the UCI protocol rather than the chess plain strength. So chess engines play like is just a placeholder here. So it's not about I can't even call it an engine. So without further ado, let's actually start. So again, like, this GUI, I was just debugging some stuff, so it doesn't really doing anything yet. So it's just still like just move validation, nothing much. I was just testing the position, and I was testing the generate captures function that I've forked from my generate moves function in order to make only captures, and that is serving the purposes of the quest and search. And just a few words about this later on. And again, like so let's go to the demonstration. So here I have the Arena GUI, and probably somewhat an interesting thing that at very least might be useful for you guys, for those of you who was randomly surfing on the internet on YouTube and eventually found this video. So let's go to engines manage and go into the details. So no, hold on a second, it's not my engine, this is my engine. So now I'm connecting the engine to this JavaScript engine to Arena GUI in a little bit different way compared to what I was doing, to how I was doing this in the previous video. And the reason for that, well, actually I was inspired by Tommy Tank Chess engine by Tamas, forgot his last name. The guy's name is Tamas. He's created one of the strongest JavaScript chess engines in the world, basically. Very interesting program. Well, anyway, so the way he does this, he just gives a full path to Node.js executable. So just to give you an idea, so okay, like probably again, like I would have been making a separate video on how to run a JavaScript chess engine that supports UCI protocol within the Arena GUI. Probably that would have been a different video, because I don't really want to make this video being dedicated to that topic, because again, like I don't have yet the plain strength to demonstrate. So anyway, despite the fact that I have Node.js installed in my operating system, just want to demonstrate one little thing. So here I've just downloaded the Node.js binary executable, the latest version from Node.js site. It's quite pretty trivial stuff, and I'm using this path to point to where the Node.js executable is. And this path is kind of command line argument. This one points to the path where my WukongJS engine actually kind of lives. So have a look at if we just have a look at, so this folder here is on my desktop, here is the chess engine itself, and together they kind of allow me to they allow me to run JavaScript CHESS ENGINE via Node.js within the Arena GUI. So without further ado, let's actually go to the demonstration. So let's start with the depth one. Again, like, I don't even have a move order in here, and assuming the JavaScript is slow as hell itself, this is gonna be absolutely weird stuff. But I just want to demonstrate a proof of concept that it supports, various modes via the UCI protocol. So here is the fixed depth mode, already with the quiescensors, so it doesn't give pieces away, which is already kind of very good news here. So these little delays are coming from the quiescensors actually calculating really lots of unnecessary nodes, because again, like, it's not optimized yet. But the proof of concept is that this program is now kind of playing chess, which is kind of really good. And if we would have been increasing the depth, it would get increased respectively. But the problem is, again, like, without any move ordering at all, because alpha beta search is extremely sensitive to the move ordering, and the more the better move ordering, the faster your engine is, and so on. But anyway, we have nodes per second value, which is, well, it's miserable from the modern chess engine perspective, but assuming that this is the JavaScript, it's not really that bad at all. And let's go further on. So the next mode, well, just to give you an idea that it just, if I so you see, like, depth is printed here. Now it would be, it's already a different game, and now it's gets stuck for much longer, because, well, not always, but when there are too many captures to calculate, it's getting stuck. And in case of check, it's just in deepening, like making depth being even more. So this weird things also happening. So I have no idea. So it still just gives. Oh, actually, this wasn't. Hold on a sec. This was a little nice little tactics. So here, actually, this bishop can't be taken, because in that case, queen would take rook on a8. So this is quite pretty nice tactics to consider. But when it comes to the blitz mode, it returns when the time is up. And when the time is up, the best move he came up with so far might be a very ridiculous move. And again, like, because of the lack of move ordering and generally very poor playing strength, it's very far from the initial release at the moment. But again, like, just to make sure that I'm demonstrating how the UCI works. So the next thing to consider, let's go for a fixed time search. So let's give it 1 second, and I just run the engine, and it just makes a move again. Like, so this would be like 1 move per second. Okay, so just let's give it I don't know, let's give it 3 seconds, just to give it a little bit more time. Again, like, now he may start blundering pieces because of why I've just explained. So now it's 3 seconds, 1, 2, 3, and it goes. The time, so there is a little lag compensation, so it actually takes like slightly less than 3 seconds, but that's just needed in order to avoid losing on time horribly. And again, like, due to the very poor evaluation, it just, I don't know, like, moving pawns. So it's not really something that you might be interested to have a look at. When I will now show you the evaluation, you will understand why this kind of weird behavior is, what is this weird behavior is caused by. But for now, just wanted to show that it's kind of like capable of taking this fixed time search. And the final adjustment, well, it also supports tournament mode, like number of moves per like 40 moves for 4 or 5 minutes. Well, actually, this moves to go, this parameter is set up to 30 by default. So even though if we're not in a tournament mode, still it's kind of like 30 moves to go is kind of constant there. But let's try blitz. So let's, well, even better to call it bullet, probably. So 1 second for a site for entire game. Okay, and let's make an engine playing it. So again, I'm really sorry for such a poor moves he's making, because at the moment I only have I have the only p-square table. Even that is not an excuse. Again, like just because it's yeah. And now here is the position I was debugging in the browser, so it just drops a knight because it's just not on time to calculate that was actually a bad idea, because it just returns from the search when the time is up, and that doesn't obviously mean that you find kind of good move. Again, like with the move ordering, he would be first looking for more promising moves, and that this sort of weird behavior should disappear. So yeah, this is the exact position I was initially debugging in my GUI here. Well, no, I wasn't debugging in here just because when I'm debugging on the server side, it also getting reflected here, because debug function is shared by both the browser mode and the console mode. So this is it regarding the demonstration, and now finally let's go to code, because there are really lots of things to demonstrate. So I've been working on this part, so UCI mode. So let's quickly just walk through step by step. So the very first thing I'm doing here, I'm setting the std encoding to UTF-8 to work with the strings instead of raw bytes. And then we have two essential functions. So this function parseGo manages the time control. So I've provided more API functions to interact with an engine, and I will quickly walk through them just right now. And another function is parse position. That parse position, here it is, that actually handles UCI position command. I will now demonstrate you this stuff in the command line to give a clear idea of how in particular this stuff works. And I don't know, for me personally, that's very inspiring in terms of something that motivates me to keep the work. And here is the command line interface using the readline module, which is standard module of Node.js. And here is the UCI loop where we simply kind of converting the line or command literally to so depending on what command is. So this UCI, we're returning this stuff. Is this ready, okay? Quit, we just exit from the process. UCI new game, we just initialize and start in position, and these two essential functions. So just adjusting the position and setting up the time control and actually invoking the search. So well, yeah, let me demonstrate you this within the console. So if I just open the terminal here and call my Wukong, so it comes to this UCI mode already. So it's just been printed here as well. So UCI sends command UCI, and engine should respond this sort of stuff. Then UCI usually asks is ready okay, means that engine is kind of initialized and ready to calculate, and then it needs some position to start calculating moves for. Well, by default is the initial position. So say like go depth 4, it just starts calculating. So it shows that time control is not being set. So no increment. Well, start time is always getting set by default, but it's not a big deal. Then it just prints the principal variation line. I don't remember if I did already demonstrate the principal variation line being collected or not. Probably I didn't, but it's not really doesn't matter really that much. Okay, so this is it. But let's say we have this UCI new game command, which is wired every time I click new game. So I see this new game here. It means that engine has just sent the UCI new game command just to prove that concept. Well, it doesn't reflect this always within the browser, so let me just try this one more time. Yeah, just okay, new game. Oh, it just okay. If I just try to send the command, is it gonna reflect? Yeah, this is it. So here is how the UCI and engine like GUI and engine UCI session starts. So UCI new game is called. We just initialize in the position. What else? Yeah, by the way, I've added this full move counter to not so. By the way, interesting thing that 50 rule move counter is counted in plies, which is a half move, and the full move counter is counted in moves. These two are the part of the FEN string. This is the last part, and this is the one before last. But anyway, then well, actually, UCI new game already initializes the position itself, but then GUI sends the command position start pause, which initializes again like to this starting position, and then it just asks engine to search for this amount of time. So this is kind of 1 minute and 1 minute and 1 minute in milliseconds basically, and then the search kind of works, outputs the best move, and then this best move is made by the GUI on the chessboard. So that's how it works basically. Okay, so what next? Just want to give you an idea regarding this section, this session. So let's say we have position start pause, and then there is command called moves, and let's say e2, e4, e7, e5, g1, f3, and here we get this position, and all this moves has been pushed onto a stack. So if there are any repetitions within this sort of a position, they would get detected, which is also good news here. So when the position has been initialized, then we can search the best move for a current given position. So let's say go, I don't know, let's say go move time and 3 seconds. So what it would consider to be the best move with this position? Well, f7, f6 is absolutely weird because knight takes, and then it's made in several moves, but it's not the point really. It was g8 to f6. It's a much better move, like Russian game. Anyway, so just to prove a concept that it's capable of interacting. So now I'm just typing the commands by hand, so that is something that the GUI is actually doing. Okay, so let's get back to the code basically. And the position command might be taken kind of to, I don't know whether I should call them arguments or not. So start pause and FEN. So we also can initialize the position from a current given FEN string. So let's say I just pick up some random FEN string from those I'm using for debugging purposes. Say this favorite tricky position. So just copy this one, and I say just so. An interesting fact regarding the UCI protocol: it's independent from the state of game. It can initializes the position from scratch every time, and then simply asks engine to calculate the best move for a current given position, assuming the moves that has been played before. So if I just say position FEN and paste the FEN, it just kind of initializes internal engine's board again, and we see this FEN string has been converted into the board position, assuming the side to move, castling rights, half move counter, impedance square, which is not available here, then half move counter, it's kind of 50 rule move with regards to 50 rule move, and full move and full moves of the game. So here we have 10 moves here. I'm not sure if that is correct number or not, but it doesn't matter, it just gets parsed, and that's good. So what else? By the way, it's internally converted into half moves because within the chess engine I keep track of search ply and the game ply. So search ply is the half move that is operating within the current given search from the root of the search and to the leaf nodes, while the game ply is the half move that represents the kind of historical move of a chess game. So it might be like it goes beyond the scope, or it can go beyond the root of the search. So if one of updates. So have a look at my make move function. So I've added this to variables like search ply, game ply, and also I've added repetition table, which stores the hash key every time before kind of making the move, moving the piece. And if we have a look at the board, then yeah, so here I've just initialized a couple more variables, and I'm also resetting them within the within the reset board. And also here I'm resetting the repetition table, so every time we're parsing FEN, like setting the new FEN, like new position from FEN, we call it internally calls this reset board. So we get this search ply and game ply being resetted there, and also this repetition table. But repetition table is defined within the search because it's something that regards to search. So I decided to define this repetition table here, and repetition table itself is indexed by the game ply. So have a look again, like at the make move, as I've been already demonstrating. So it gets indexed by the game ply. So the more and again, like every time we make move, the search ply and game ply gets increased. Every time we take back, they get decreased. But here, oh my god, here they get decreased. But in case if we are loading the kind of game state, so just go to my load moves function here. I'm kind of validating the moves here. So I just need to take this, let's say this move string. No, it's just a principal variation. Yeah, let's say I want to take this move string. Sorry, I've been distracted a little bit. So yeah, let's say we take this move string. So we need to convert the board state to represent the position that would appear after this move. Moves are actually being made on the chessboard. So here is the routine to load these moves. And again, like an interesting fact that I've made a little more refactoring. So now this load moves is not only used by the UCI protocol, but also by the move piece function, which is the GUI. The GUI routine that actually validates the user move. So before I was doing this separately, but now this load move is actually used by the GUI function as well. The difference is that the GUI function only takes the single move, the one that user is the one that user inputs on a chessboard, but the matter of validation is the same regardless of the number of moves. So this moves might be the only move as well, as it happens if, say, we just say position start pause moves e2 e4, and that's already a valid position. So that the only move also can be validated because we just splitting the moves by the space, and if there is nothing to split, it would return only the single move to work with, and that's kind of it. So so yeah, here we just load our moves. And what I wanted to mention, because when I was initially working with these repetitions, I had no idea regarding the difference between this kind of search ply and, oh my god, my cat wants to get out from the house for a while. Oh my god, she's torturing me every time I'm trying to make a video. Okay, maybe she won't. Okay, so I didn't understand the difference between the search ply and the game ply before, because I didn't actually see engines that call these two variables like this. They usually call it like ply and history ply, and it's not always that easy to figure that out, like what kind of history are they talking about. So but search ply and game ply seems to be more meaningful variable names. So search ply is the Halfmove that relies within the search scope from root node and until the leaf nodes. Okay, my cat is starting going mad. Okay, sorry guys. Yeah, and you remember that we do increment both the search ply and the game ply within the make move functions function up there. So if we do if it's just a matter of loading the moves to initialize the particular game state, we then need to reset the search ply back. So in order to avoid confusing the search actually. So search always starts with the search ply equal to 0 and ends up with a search ply equal to 0 as well, because the matter of how many moves we make is during the search, and then we will take back exactly the same number of moves. Otherwise, the search won't be actually working, and that's why perf testing is that's why the perf testing exists, basically, just to make sure that the number of moves made on board and the number of moves being take back. Okay, guys, I'm sorry, just need to let her out. Sorry, hold on a sec. Okay, I'm sorry, just can't really do much about my cat. I have 3 cats basically, and there is a cat from another cat who's coming from somewhere. So I don't know who is his kind of owner, but he comes to my place to eat something, and quite often he sleeps on my bed as well. Well, it's not my cat basically, but anyway. So I just love cats. Okay, so we need to make sure that we reset the search ply. And an interesting thing that before this implementation, which actually how normal people usually do, so when we do increment the search ply and the game ply within the make move function and decrement them within the take back function, that's how the normal people do. But what I was doing before, even in my didactic BBC chess engine, okay, even in my BBC chess engine. So, okay, guys, I'm just sort of this environmental sound. My cat didn't really want to go out, so she just want to create a total disaster in the house now, and I can do literally nothing about that. I'm sorry for that. So some environmental sounds might have been around here. So if we have a look at the source code, if we just have a look at the source code, then again, like this is absolutely weird, but I was doing this just to give my own self an idea of where exactly the ply and the game ply, here I call it the repetition index, but literally it's the game ply. So where the increment and where the decrement actually where it occurs basically. So it happens like every time we're making move and every time we're taking the move back. So ply minus also happens every time we're taking the move back. But you see, like, it's outside of the make move function here in particular, which is kind of a bit of a pain to maintain. But again, like this did let me to realize how exactly this ply and game ply, like search ply and game ply, work, and what's the difference between those two. So like when you take in some solid chess engine from scratch and try to read through the source code, trying to figure out how it works, some places within the source code might be absolutely unclear because you don't see the steps that the author has walked through in order to come up with that sort of an implementation. And like that's the reason why I decided to start in the most dumb way possible and then just try to optimize it again and more and more, and eventually ending up with something that normal people actually start with. But again, like this gives an experience which gives you a consciousness. So okay, guys, sorry, just one last time. Oh my god! Finally, she agreed to go outside to have a walk. I mean my cat. Okay, so I hope there won't be. I hope the two other of my cats are now sleeping and not gonna be torturing me now. Okay, so yeah, that was regarding the search ply and the game ply, and I have another difference regarding the matter of refactoring, basically within the implementation of move ordering. But as far as the move ordering is not yet implemented, I will probably cover that in the next video, pointing out to the difference between my early implementations of move ordering, how in particular I was doing that, which was crystal clear, but not really that fast. And now we would be going for a faster way, which is not really that crystal clear, but again, like when you're walking through those steps from the bottom to the top, you're starting to realize how the things work. And again, like that's all the matter of consciousness. So the deeper you dive into it, the more the better, the more clearly understanding you're getting in return. So this is kind of almost it, I believe. So again, like regarding parts position and parts FEN, I've just demonstrated how they work. So we can either initialize the starting position and then make moves from that, or we can initialize the FEN. Yeah, we can also make moves from the FEN. Didn't demonstrate that yet, but just let me quickly do that. So position FEN, and let's say here I want to say E6, E2 takes A6 and B4 takes C3. So let's say E2 takes A6 and B4 takes C3. And here we get oh my god, I just hold on a sec. E2. Hold on a sec, it didn't parse the moves. What did I do wrong? Oh, I didn't say moves. Oh my god, I just didn't say moves. Okay, sorry. I need to say moves. E2, A6, and B4, C3. And yeah, now we just taken this bishop with this bishop and taking the knight with the pawn. So here is the position has been updated. We have another full move being added. No, there wasn't the 50 move rule kind of wasn't available because there were captures before, I believe. So here again, like every time we move a pawn and make a capture, this 50 rule move counter gets resetted. So just another thing to bear in mind regarding the feeder rules of chess. Okay, and regarding the parse go command, it's also quite pretty simple. So something that I was making in my previous engines. Again, like this logic is taken from Vice by Richard Albert, also known as Blue Fever software. It's a little bit changed by me. Well, here I'm using the hard-coded indices to match the particular place of the command within the command string when I'm parsing it, which is generally a bad practice, but assuming that it doesn't happen, they don't change the order. The GUI never changes the order of these commands. Well, at least Arena GUI doesn't. I don't know. Maybe some other GUIs change the order. In that case, this code might not work. But if someone reports me that issue, I will probably change this code. But for now, I just want to make it as simple as possible, like I always do. So here we have two types of variables, and again, like before I was using all the global variables. Well, now I'm distinguishing between them. So these variables are those that regards to the current go command, regards to the current search. So every time we want to search a position, we're getting a new go command. Let's say go like white time, black time. Sorry guys, you would just have a look. So every time we have this go white time, black time, and when time runs away here, it would be this white time would be last, the black time would be last again. If there is an increment, it would get added also as well. If there is a moves to go, like in tournament mode, it would be appended as well to this command. So every time we're parsing this sort of a string here within the parse go command, and we need to initialize our time control variables respectively. But a very important thing that from now on I have this timing.time. So timing is the pointer that is returned by engine.getTimeControl. So I've added another function to the engine API. So now I can retrieve the variables that regards to timing. So let me just quickly show you how this timing kind of works. Okay, let's do it a bit different way. Timing. Okay, So it has time set, which means that whether the time control is being set or not. So if we're going for a fixed depth search, this time set would be equal to 0. And again, if we are about making like fixed depth search, we don't need neither time set nor stop time nor stopped. So this stopped is the flag, nor time nor increment. So none of this is needed when we're searching for a fixed depth. But when we're searching for either the fixed time per move, like 1 second per move, or some different like blitz or whatever time control, in that case this variables comes onto the stage. So time set means that we're using time control. So if it's set to 0, so every time, so I reset the time control every time parsing the go command, by the way, that is right in there. Stop time tells the engine when actually to stop calculating, and then it returns from the search function. Stopped is the flag that actually flags that the search is no longer permitted. Time holds the milliseconds of how long we can search basically. And increment, oh my god, yeah, and increment shouldn't be here. Actually, I just need to remove this increment because yeah, increment is something. Yeah, I was just cleaning up this sort of stuff. Sorry guys, just we don't really need the increment here because yeah, because the increment is getting initialized every time. Here it is. Okay, so anyway, and then we're just calculating the time that we're allowed to search. Obviously, if we were within the time control territory, so it's not equal to -1, which means so here it gets parsed like or it gets parsed here. So either like blitz or fixed seconds per move. So in this case, we actually, yeah, and just like I was mentioning here, we say engine.reset time control. So we just resetting this up, and this function is interesting. So engine get time control. So it returns the pointer to the timing variable that is declared within the engine, and this is done just to make sure that all the variables are in there. So if the developer has no idea like what should be in timing, in particular if he forgets to set up something, that this timing would be holding all the variables within the object needed. So then we just can change whatever inside timing we need. So we're changing the time set, the time, and stopped is changing within the engine. That's the matter of logic of time handling basically. Did it show how this happens actually? So let's go to Nigamax search. Yeah, I also wanted to walk through the search quickly, but probably I will leave this to the next video because yeah, it's still pretty raw, nothing much to say. So every 200 and 2047 nodes, we're checking whether the time is up or not. That's why this communicate function is used. Maybe I should have, well, it's called communicate because in my previous implementation was also responsible for killing the engine process or at least stopping the engine from calculation on demand, while this version doesn't have this feature, unfortunately. And even much better engine than my Wukong, well, let's say Tommy Tank Chess doesn't have this feature as well. I even wrote to the author asking why is that so. I'm not sure if maybe he did he respond me? I'm just wondering. Probably, I really doubt that he did. Yeah, no notification, so probably okay, just forget that, doesn't matter really. And here it is. So if this timing stopped, so if stopped flag is equal to true, then we return from our search. That's how this works. And the communicate itself, well, I should call this kind of like is time up or something. Yeah, probably I should rename this function to is time up or how long, like something that regards time, because it's not communicating with a standard input anymore. It doesn't. So here again, like if we have this mode for time control being set to 1, which means kind of true. So it means like we do in the time control territory, and then we're just comparing the current time in milliseconds with the stop time, so the time when we actually need to drop the search. So if it's more than that, then we making this time the stop flag equal to true, and then as soon as search gets here in the iteration it currently at, it just oh no, sorry, it's not here. Here it just returns 0, and then within the iterative deepening, let's say, where is my, oh my god, iterative deepening here, let's say he was searching like depth 5, but then he just drops, and so he goes to the next kind of like the next iteration, and then he suddenly sees that, like, okay, so time equals to 1, which meant that we should break, and we just break from here, and then we just output the best move, and we don't bring the principal variation because we kind of drop the search. So we just whatever principal variations we printed before, that's good, but then we just need to output the best move, and that's kind of it. So that's basically kind of it. Well, okay, guys, I'm sorry for was a little bit unstructured explanation probably, but again, like I'm just so happy to finally have this UCI interaction being established, because it's incredibly handy for debugging purposes. So now I can comfortably debug my search and evaluation. I can make my engine playing versus itself. I can play versus my engine. I can make my engine playing versus other engines. So all those, so actually from now on I can run tests to test my engine, and all the development it's all about testing. So all those tests might reveal some possible bugs, and that's the way to go basically. So without this UCI interaction, it would have been incredibly difficult to debug it actually. So, and as soon as I would get relatively satisfied with the plane strength, well, obviously it won't be like super strong, but at very least when we would be having at least something, then I will go back to GUI and actually make it possible to play versus engine in the GUI. And then I have many interesting ideas in mind, like bearing in mind the fact that actually really the API for this engine is growing. I would probably like to create both some documentation explaining how to make use of this API, so we can do really lots of interesting stuff, or interesting things already now at the moment, but it would be much more functions here to use basically. So it won't be only the chess engine, but also a chess library as well for both the front end and the back end. I just need to distinguish between these two modes in terms of API, which might be a little bit of a pain, but anyway, that might be interesting. So an interesting task to consider. So I can see two major approaches. So the first one is actually providing some visual examples on kind of like making this engine working in different modes. Like, let's say we can just play versus it. We can make an app with the graphical elements to change the evaluation parameters, let's say. So we could have changed the evaluation parameters and see it in the live mode, like how the style of playing is getting changed when we change, let's say, the positional square table or material weights, or positional square table weights. Maybe if there would be some additional features within the evaluation, they might be changing from the GUI as well, which might be interesting to play around with. Another possible mode or option is a PGN reader. So like imagine that user is copy pasting the game into the text field and clicks the load button, and then he can just walk through the PGN using the engine, because in order to walk through the PGN, we need a chessboard representation, we need a move stack to push the moves onto, and again, like this load moves function that I've already created it would be extremely helpful in regards to this sort of stuff. And it's really I really love the fact that this load moves is separate from the particular PGN format. Well, obviously, probably one day I will need to write a PGN parser, which is a big project itself, and it might be a bit of a pain to make it bug free, because there are really lots of notations available. But anyway, these core functions like load moves, I would actually load to load moves into the internal board and to the internal board stack, so would be able to walk through the game back and forth, like making moves and taking them back. It's literally what the search does. So it's all the matter of what am I trying to do here, guys? I'm just trying to provide some sort of a core functionality, the very basic core functions that allows us to manipulate the chess engine's internal board state and the game state, like position and position and game variable state, and then we can build something more complex on top of this fundamental functions. And what am I now working at is I'm just trying to make this fundamental functions bug free, and to make sure that we can rely on these functions. And probably another thing to mention here, that at the moment I don't have handlings for some illegal, well, let's say, just want to show you the API to point to the issue directly. Oh my god, where is that? Yeah, here it is. So let's say we want to say like set board and FEN. So if user would input an illegal FEN, it would just cause the undefined behavior from the engine. It might give an error in the console. It might be just silently passing through and then crash when it comes to the search. So it's not good. So there should be some validation. But again, like that would be added later on. Same for load. Well, load moves would just silently drop those moves that are not valid. But again, like from the developer's perspective, it's not really that great. So it would probably be better to know for sure whether your function succeeded or not. So you see, like I'm not returning the values from the functions. I'm just calling this function. So it's just a matter of encapsulation at the moment. So I'm not validating the fact whether the function succeeds or not. Same with a get piece or get piece or set piece. So let's say we try to set the piece off board. That obviously would get set, but that's definitely something that we should avoid, and that's something that should never be happening. So I just want to trying to give you an idea of what in particular is missing here at the moment. But again, like there are really so many things to consider that it's incredibly difficult to hold this in one little head, basically. Yeah. So I'm just trying to show you that then even when you're not capable of improving your chess engine anymore, there are tons of work actually left that you can work on. And the interesting thing that if you say you're stuck with improving your chess engine and you don't know what to do, so you can do this tiny little routine things, and you just getting rest from some complicated ideas to improve the performance of a chess engine, and then suddenly some smart thought could have come into your head eventually, and you'll suddenly realize how you can make your engine a bit stronger, a bit faster, things like that. So I hope this is clear. So it's kind of an incredible playground to develop your own programming skills basically. And I really love projects like this, because it's the matter of it's the place where you can do whatever you want, because you're not doing this for a client. And for those of you who are freelancers like I am, you'll probably understand what I mean here. So it's incredibly important. If you're a freelancer, it's incredibly important to make something for your own self, where nobody's forcing you to write the code the way they need, but you can write the code like you understand, like you want, and then you can improve, and then you can come to the best practices, not because you just believe in best practices, but just because you realize that that's just the better way of doing things. And well, at least that's the way how it works for me personally. Okay guys, this is it from my side. I'm sorry this video was a bit useless to you, or not very exciting, not very interesting, but I just wanted to share rather the development progress and how this looks like from the internal perspective, rather than sharing some particular results at the moment. Results are coming soon, hopefully, so those would be shown as well. But at the moment, I just wanted to share this. What am I doing inside, basically, for those of you who making something similar might probably get inspired by this. Well, at least I hope so. So again, like I just made too many things to cover in the single video, but even now I don't really even in the tons of work being done here, but it's not really seen basically. But I don't know. So I don't encourage you yet to test this engine in the UCI within the via the UCI protocol, because there is nothing really to test from the chess playing strength perspective, but just as a proof of concept. So maybe you could have used this sort of a code in your own projects if you have a chess engine in JavaScript, or if you have some chess engine in JavaScript that you didn't write but you want to play with using via the UCI protocol. Well, I was thinking like maybe I should make a JS version of Wise Chess Engine written by Richard Albert, also known as Blue Fever software, to be capable of playing via UCI. But that's a little bit of time consuming, so probably won't be doing that. But anyway, that might be an interesting project to consider, just trying to pick up some sort of a JavaScript based engine and try to make it playing via UCI protocol, which using Node.js, obviously. This might be quite a pretty interesting thing to consider as a hobby project. Okay guys, so this is it from my side. A new report on the development progress is coming soon, I hope. I will now be working on actually search and evaluation, so we'll be trying to make it stronger, and the next few videos most likely would be dedicated to that. And then we will go to, as soon as I stuck, we'll go to implementing the GUI, and then we'll see what happens next. So this is it from my side. I hope to see you in the next video one day. Until next time, and take care.